I welcome you all for the 34th lecture. I hope everybody is able to see the PPTs as well as the video in the corner. Nobody is facing any difficulty. And today we are going to, there is a fixed agenda I already circulated with you on the WhatsApp. So today what we are doing is that we are trying to understand the concepts from theory. What is theory behind that? How the translation is done on the fly, means what is happening in this particular unit. Actually, as I told you in beginning, that it is not necessary that every compiler, whatever compiler you are using, like production compilers like C, Java, or Pascal, or whatever, you are using same technique in those compilers. Normally, compiler use whatever you learn in terms of phases, means that things is implemented into the compilers. But there are some applications like Google Map or voice control car, or there is something language translators are there. I have given you the example where on one end you talk in some language, say English, and on another end you listen in some other language, say Japanese, like, or Chinese. So this is a technique or the way in which we are not thinking in terms of traditional way of the compilation. Here we are thinking how to translate the programming language construct or any source statement, string ups into target code or target representation. Actually, you should call it as a representation. We don't know. It depends on the application whether you want intermediate representation in some graphical form or tree form or 3 address code or 2 address code or maybe 0 address code. That depends. So this is kind of translation directly from target. And here we're not doing the things whatever we done in previous techniques, like in top-down parsing, bottom-up parsing, lexical analysis. We have seen the things, and we are not doing the traditional way semantic analysis in this typical SDT, that is a syntax directed translation. So that you have to think. So don't directly correlate the whatever you learn in this unit with the actual compilers. So it is not necessary, as I told you, but there are some compilers which may implement. It depends on their client requirement. It depends on the client requirement where they can implement SDT directly in the translation. So we are going to think about certain things, that how it is done. So as I have given you direct some background, like attributes. So I try to discuss about there are different types of attributes like synthesized attribute, inherited attributes. We try to understand that synthesized attribute is nothing but if you have a tree, so you calculate the value of that attribute from child of that tree, means node. And in case of the inherited attributes, how we calculate the values? We calculate the values from sublinks or parent. Means you consider parent also, whatever node is there, it has some parent. So you consider the values of the parent as well as values of the children. So you consider both. And there is some refining. Means you consider the right sublink, sometimes you consider the left sublink, like so that is there. So this is concept only. We are not learning exactly what is done. So difference is that in synthesized attribute, only values of the children are considered, and in case of the inherited attributes, values of the parent node as well as sublink is also considered. So are you able to listen me? There is some noise, motor noise. So before going ahead, just Please raise your hand for 1 second so that I will understand. Okay. Thank you, Chetakshi, Tanmay, Sakshi, Tanuja, Mandar, Chinmay, Sahil, Suyog, Homeshwari. So people are not raising hands anyway. But I think if your teachers ask you something, you should do it. So Viplo is there, Umang is there, Tejas is there. Om is on the hold. I don't know what he has done on his side. So only 15 students have raised their hands. Gauri has raised her hand. Viplo, Umang, Tanmay, Suyog, Shivani, and Sahil, they are not raised their hands. Anyway, I will go ahead. So those things in mind, no matter we are going to see the concepts behind the translation. So there are two terms, whatever we learn, something called as a SDT, syntax directed translation, and there is another term that is SDD. So I have given you enough material in previous lectures. You download it, you write it in your notebook, and you should have a perfect definition for SDT, because they may ask you, you have to explain SDT with example. You have to give some definition and some example. In the same way, they may ask you, what is SDT? So you have to give definition and example of that. And sometimes they may ask you to differentiate. Actually, it is not difference. SDT and SDD is something, same thing, but the concept realization is a little different. So we are going to clear that in today's session. So I hope you will understand at the end of this session what is exactly the difference. So let us go ahead. So this is the agenda. So we are going to revise concepts in terms of definitions, what is SDD and STT. Then we are going to see what is S attributed definitions, L attributed definitions. See, attributed definitions means what? You have a production rule. So there is something called as a table is there. You have on one side, there is a production rule. On another side, there is a semantic rule. Something like T dot val, E dot val, or whatever. So if your attributes, so that T dot val or E dot val is nothing but it is an attribute. So if it is a synthesized type attribute, synthesized attribute, then we call it as a S attributed definition. If all in semantic rules are synthesized attributes, and if all the attributes in semantic rules, second column, they are inherited attributes, then we call it as a L attributed definition. If all the attributes in a semantic column, semantic rule column is inherited attribute, then we call it as a L attributed definition. But there can be some cases where there is a production rule and there can be multiple semantic rule for one production rule. Whatever example we have seen up till now in previous session, they were containing only one rule, one production rule, one semantic rule. But there can be some situation where there can be multiple semantic rules for one production rule. So that can be there. So the way of calculating, even though there are multiple, that is not a problem. Problem is that how to calculate the values. So for synthesized attribute, you have to consider only children. For inherited attributes, you have to consider parent as well as right or left sibling. That is there. Then we shall see what is difference in synthesized and inherited attributes through some example. Then we shall see translation scheme. And I will try to talk about the top-down translation example. Possible to cover it in maybe 40 minutes. So we may go in next session to discuss that. So this is short. So translation, SDT means what? How to do the translation. That is the concept. So in SDT, there are actually 3 techniques are there. So one can be the rule-based method. The second can be the oblivious method. Third can be whatever you see the previous material. And SDT means definition used to evaluate the meaning of the programming language construct. So it is how to derive the meaning from the statements or programming language construct. Programming language construct means that it is a set of statements, the source code, like that. So it can be single statement or it can be multiple statement. So it is a way how we derive the meaning, that is called as SDT. And SDT means a way how we do the translation. How we do the translation, we can use top-down method or we may use bottom-up method. That can be the one way. Or we may do the translation by using some rules. So that we shall see later. But I think at this moment, this is sufficient to note in your copy that what is the meaning of the SDT. So how to do the translation, that is it. Now, this is the only definition. You can take the screenshot. We know what is AST, Annotated Syntax Tree. I typically talk about like a decorated tree. Means what we do, we derive the given sentence. Means we parse that given sentence, and from that derivation sequence, we construct the parsing tree. Once we construct the parsing tree, then we attach attributes to the nodes. And then we attach or add values into those attributes, whatever the attributes are there. So parse tree, which shows the values of each attribute at each node. That is the AST. Second is that values of the attributes of each node at AST is either initialized to constants. Means just like in the program, normally you initialize some variable like x is equal to 0 before using it. And somewhere in some procedure in your program, actual code, you use that value, so variable. So many times we have to initialize it to some value. It may be constant or you may initialize it with some 0 if it is a integer or like thing, or maybe real type thing. And normally the initial value is, we take the initial value from lexical analyzer normally. Or there is another way how to get the values for those attributes, that we can refer the semantic rules corresponding, whatever the production rule is there, we refer the semantic rule, and by that semantic rule, we determine the value of typical attribute in that tree. So tree is given there in corner. It is not visible to you, I know, but we shall see later. And from that AST, whatever we build, first we build the syntax tree or parse tree, then we build the AST, that is called the decorated parse tree, and then from that AST we build the something called as a dependency graph. So today we are going to see what is a dependency graph and how to use that graph to evaluate or to derive the meaning from the given PL, programming language construct. So dependency graphs are used to evaluate the values as well as the evaluation order. Let us see this term. we use dependency graph to evaluate the values of the attributes in the AST and the evaluation order. Now, what is the order? Order evaluation means what? We traverse that tree. As I told you that there are different ways to traverse a tree. It may be pre-order traversal, in-order traversal, post-order traversal, or it may be BFS, breadth-first traversal, or it may be depth-first traversal. Like, so we traverse that tree, and while traversing that tree, we compute the values of the nodes. So dependency graph is very, very important. So it tells you the evaluation order, that how to use those roles, in which sequence we have to use those rules to calculate or evaluate some value. So I think you have taken the screenshot, or you can download the slide. So anyway, this is a simple definition for the dependency graph. So dependency graph, as its name tells you, that if you want to calculate the value of A, then it depends on some other variables like B and C. If you want to calculate the value of B, so the value of B depends on value of D, like, so it is dependent on someone. So this graph is simple. You can interpret it. And this is concept. See, there are different ways of realization of dependency graph. It depends on the application where you are using it. Normally, dependency graph is a directed graph, and it is acyclic, means there is no loop. If a tree has a loop, then it becomes graph. You know the difference in a graph and tree. So let us go through the definition. So dependency graph is a directed graph representing dependencies of several objects. Objects can be variable or attributes towards each other. So that arrow tells you who is depending on whom, like that. So E is depending on B and C, values of B and C. B is depending on value of D, like that. So if the value of D changes, ultimately value of A also changes. So that's why it is important to understand this thing. If dependent value changes, then some attribute value may change. Now, second part is there. It is possible to derive an evaluation order. See, there is a term. It is possible to derive an evaluation order or absence of evaluation order. So what I want to say is that the graph or dependency graph, it may be in such a structure that or complex structure that it is not easy to identify structure of the graph. That's why it is written. It is possible to derive an evaluation order or absence of evaluation order. Means sometimes it is not possible to derive the evaluation order, how to calculate. For example, in this example, if you want to calculate value of A, you have to consider values of B and C, like that. And indirectly, value of A is depending on value of D also, because B depends on D. So sometimes it is not possible to derive the evaluation order from the given graph. So I think it is making some sense. Anyway, so there are different types of dependencies. Why it is called as a dependency graph? It is very important. I don't know, but in OS also, or any multi-processing environment, you can use this concept. Or in higher subjects, you will be learning something called as a deadlock. So there you can use the concept of dependency graph to solve the deadlock in an efficient way. So deadlocks is normally what? There can be some resources, limited resources, and there can be large number of processes running into the system. And the resources can be memory or memory location. It can be printer. It can be keyboard or bus. Bus is used to transfer information from one uh, register to another register or some location. So they are limited. So every time we have to lock them. Otherwise, what will happen? Everybody will try to use same bus. Bus is only one. So that will cause chaos. It may cause the deadlock. So synchronization is required. That's why you learn something called as a semaphore in various subjects, other subjects. So right now it is not necessary to talk about the semaphore and all that. So we are just understanding the basic concept. So what I want to say is that, so dependencies can be derived. It depends on type of dependency. So something is called the pro-dependency, anti-dependency is there, output dependency is there, control dependency is there. Control dependence means what? Say you can take the example of a lift. For example, uh, one person enters into the lift. He is on the ground floor and he wants to go to the 10th floor. So what he do? He pressed button 10. Lift will go. Now lift is traveling upward. So somewhere in some floor, he stops that lift and he enters. And he wants to go to the, let us say, 5th floor. He press button number 5. So system should work. So the lift will not go to the directly 10th floor and then it will come to the 5th floor. What will happen? Lift will stop to the 5th floor. That person who entered into the middle somewhere, he will leave the lift. And then the first person, he will continue his journey to the last floor, like that. So you can see, you have to correlate whatever your real-time situations with the theoretical concepts, whatever you learn in subject. So that is called as the control dependence. So in many logical circuits, you might have learned about the STLD and all that. So the concept of dependence graph or dependency or types of dependencies is very, very important. So it is very important in terms of real-time application also. For example, in airplane, passenger plane or Boeing or whatever, nowadays, the landing system and takeoff system, when plane comes and lands on the airport, that system, and when it takes the takeoff, so that is automated. Pilot cannot do anything. So that is controlled by the computer system, automation. So there are many events are there. So ऐसा हुआ तो ऐसा नहीं करना, वैसा हुआ तो वैसा करना, like that. So that is mapped in terms of some dependency graph. And in this way, that whatever the control system is there, maybe working in some real-time area. I have just taken the example of airplane. Otherwise, there is something called the autopilot is also there. So that time also pilot don't do anything. The system takes the control and it travels, the plane travels on the due course. Course means जो भी उसका destination है, direction है, turn वगैरह, left, height उसका, सब उसका automation होता है. तो internally, that thing is implemented in terms of, realized in terms of dependency graph. And the nodes has some values depending on some priorities. The value changes and the system works automatically and it responds on any emergency, like that mode. You are going to the long distance, say 500 kilometers, and there might be 2-3 turns and all that. There might be some places where you are lowering your height from the ground, and suddenly atmosphere weather changes. So the computer system senses that thing. Is change in weather, change in the airspeed, uh, air, and depending on it takes the decision. And on that decision, it may change some course, right? So that is there. So this is the very, very important concept of dependency graph. So, so just for time, means a theoretical purpose, you just remember this. I will talk about it because I don't wish to do the interactive session on that. We can do it. We can talk a lot much on this. We can consider a lot many theories also, or some theoretical examples, and we can understand how it is important. But what I suggest is that whenever you get a chance, maybe through Google or maybe through uh, YouTube videos, you try to learn about as much as possible about the dependency graph, because it will help you to understand the application, real-time applications, how they operate. That is automation. So anyway, there can be different types of dependencies. So even in databases also, you have to learn about the dependency. So that is called as a functional dependency. Uh, so I have just listed here four. If you search, you will find many more, and it depends on the area and domain also. For example, if you think in terms of database systems, then there will be different dependence variables or values will be there. If you think in terms of the real-time systems or microcontroller systems or operating system, then there will be different things. But these are simple. From that, you can flow means what? Flow of control or workflow. You just try to understand what is the workflow and all that latter. It's not necessary for exam point of view, but conceptually it is very important, because uh, at the end you will be working somewhere and you are doing some kind of automation. It may be just like a ATM like system, means ATM like transaction, means you are using card or smart card or something, fingerprint like. So if you map that process, whatever is there, process means that task in terms of dependency graph, then you can design your system in very good way. So these are few listed anyway. I hope it is sufficient for today's whatever scope is there. So, and this is description, later you read it. It is not necessary from compiler point of view. The flow dependence, anti-dependence, output dependence. So it tells you how to calculate. For example, for example, D, B, and C. These are the variables. So it may be output dependent variable or control dependent variable, like that. So depending on the type of dependency, the calculation varies. That is what I want to say. So I'm not going to confuse you, because we require only simple thing to understand the concept. So let us just go through this slide. This is sample example. So many engineers who design the plan, just like architecture designs a plan. So when there is a code, so you can draw some dependency graph. See, in code, what is there? There can be some variables can be there, loops can be there, or certain control like if then else case can be there. Like, so always there are some variables who depends on some other variable. So you can draw them their dependence in terms of arrows. For example, line number 1, 2, 3. So in line number 1, there is a variable A. A is equal to B plus C. And in line number 3, there is on right hand side, there is a, you are using variable A into EI. EI is a array. So there are different notations to represent the dependency, like flow dependency array, anti-dependence. There is a dash line. Then output dependence is there. Then you have to mark some circle on that edge. Like, so this is sample example, and this code is a Fortran code. There can be some any other code like Java or some other code. So in this way, uh, flow of control can be represented by using dependency graph. That's what I want to show you. Now this is homework. You take the screenshot of this, and for verification you send me on personal WhatsApp. So this will help you to clear the concept of dependency graph. So first question is how to draw the dependency graph. You have to learn about the applications of dependency graph. I have given you just few explications, but you should be able to write in copy in terms of some lines in your copy, and then try to learn about the DFS, depth first traversal method. Yes is for search. You have to just tweak it. So you have to get some graph, sample graph, and you have to explain how to traverse that graph, how to visit the nodes, how to traverse the edges, and how to visit all the nodes in that graph, given graph. So it will clear the idea how it works, DFS algorithm. And there is a last term, that is a BB. It is called as a basic block. You just try to search what is that and what it means. So I hope you have taken the screenshot, and someone, or I think you will send me on my WhatsApp that you are doing it, because when I ask you to raise hands, the only few students raise their hands. So this is something what we do. As I told you, we first build the parse tree, then we build the AST, and from AST we build the dependency graph. So you have to learn why we are doing this, why we are building dependency graph from AST. So I think I should not ask you, but I think you got it. As I told you that dependency graph tells about the evaluation order, how to evaluate the meaning, like how to evaluate it, in which order we have to evaluate the meaning. See, there is a production rule, there is a semantic rule. Semantic rule contains some attribute. It may be synthesis attribute or it may be inherited attribute. Now, semantic rule, every semantic rule has some number, like production rule. So in which order we are computing it, that is what a dependency graph tells you. Dependency graph tells you in which order you have to compute the semantic rules. So parse tree to syntax AST to dependency graph. This is what happens in SDT, syntax directed translation. Now this is theory. Just go through it. Later I will be showing you what exactly dependency graph is drawn or generated. So later I will read it, but I suggest you to download this slide, and later in maybe next session we shall think how it is done. Now here I'm just giving you one example. Let us say this is the example. So it is very simple example. So this is called as a basic block. See, uh, all the statements are closed into block, brace bracket, and they are belonging to only single task. For example, you are here, uh, there is a variable n, it is an integer variable, and there is some computation like n is equal to a plus 1, x is equal to b plus c into n is equal to n plus 1, y is equal to b plus c into n, like that. So 3 or 4 expressions are there. So they all belong to only one task or one job. So in a big code, you can identify the basic blocks. Basic block means what? The particular set of instructions which are near to each other and they are related to only single job or single purpose. So that we have to carefully identify and group them like that. So let us say that this is a basic block. And the basic block can contain multiple statements. It may contain multiple control statements, or it may contain simple arithmetic statements, or it may contain some simple programming statements जो भी अपने program में रहते हैं वो. So a basic block consists of expression or assignments. It is not necessary. Then the next statement is identified by semicolon. For example, in this example, there can be some other notation in another examples. So it is helpful because it tells you up to what point or up to what mark you have to do the computation. And then you have to build the AST for it. So first, what we have to do? We have to consider grammar. We have to parse this set of statements. From that statements, we have to generate the parsing tree. From that parsing tree, we have to generate the AST, and means we have to decorate that parsing tree. We get the AST, and then we have to put the values into those attributes of the ASTs. And then we have to traverse that AST. Once we traverse that AST, then we will get the meaning. Meaning means actual answer of that particular thing. Meaning. So meaning doesn't mean that a plus b is equal to 3. That is not a meaning. Meaning has a very large meaning. Means try to understand it. Meaning means intent. What is it for? For example, these are the set of statements. So what is its intent? उसका meaning क्या है भाई? किस लिए है ये? So that is there. Meaning doesn't mean simply translation. मतलब suppose if I say मैं मतलब I, it is not a meaning, right? So that if you have multiple statements, then you have to think in terms of intent. So anyway, so let us say this is a syntax tree or a parse tree. Now see here, you take the screenshot and compare with the set of statements or basic block. See what is happening here. N is equal to a plus n. So this complete parse tree is representing the set of code, set of statements, or or you can say basic block. So, and this is logical. See, there is a equal to sign. See, don't worry about the order right now, but you will find that it is as per given in the basic block. So a plus 1 is equal to n is there. This is tree, leftmost tree, or sublink, or you can say subtree. Then it is separated by semicolon. Then again, x is equal to b plus c into n. It is given there. I don't know whether you are able to see the mouse movements or not. I hope you are understanding it. Then third statement is there. N is equal to n plus 1. So third subtree is there. You see that. So in this way, the tree is equivalent representation of your basic block. Basic block is a set of programming language statements. So this is syntax tree. Now, we can build AST from this syntax tree. So here we are not building the syntax tree right now. Here, this is an example of the dependency graph. So in next session, I will be taking simple examples, and you will be able to compare it, that how to construct a AST dependency graph from the syntax tree. So it may be complicated to you, but you take the screenshot of this. I will be taking single line statements where we shall first build its parse tree, and from that we shall build dependency graph from that. In exam they don't do, but this is only a concept. We are understanding what is a dependency, because we want to understand what is the evaluation order. So anyway, as I told you, you don't worry about it. I will be taking single statements, and then we shall building the parse tree and then its corresponding dependency graph. So there is a way to minimize the dependency graph. See, everywhere there is a minimization. For example, if you learn DFA, you can minimize it. There are different techniques. In the same way, if you have a dependency graph, you can minimize it. So depending graph minimization, you have to, what you have to learn, you take this as a screenshot and try to find the application of minimization of dependency graph and its importance. See, I am telling you what is importance. What happens is that when we have a parse tree, we build AST, then we build dependency graph, then we try to minimize that dependency graph. And once we have a minimized dependency graph, then we can generate intermediate code. Ultimately क्या हो गया? If we have a minimized dependency graph, हम लोग minimize optimum intermediate code generate कर सकते हैं. So minimization has importance. It minimizes or it helps in optimization of intermediate code. That's it. You keep this in your mind. Dependency graph helps you to minimize the intermediate code that is there. So later we shall talk about it in detail later. Now this is algorithm. You just go through it later, and then think about it later. So this is a depth first traversal algorithm. It is very simple. What you have to do, you have to start from left to right, and then recursively call same function, that is a visit. Visit is a function. It is just like a pre-order traversal or in-order traversal or post-order traversal. Same logic is used here. Same logic is used here. So I will be talking about it, but today I am just giving you theoretical things, and tomorrow or in next session we shall work on some example. So you take this algorithm, it will help you to understand the depth first traversal. In same way, try to get the BFS algorithm, breadth first algorithm. So this is something. See, you are familiar with this tree, right? So this is a AST with the values, attributes. So for example, here all the attributes are synthesized attributes. And here grammar is given to you, right? Grammar is given to you. Every grammar has some number. Oh, sorry, every production rule has some number. And you have to compute 9 plus 5 plus 2. 9 plus 5 plus 2. So it will be definitely 16, right? So how you are traversing? See, you follow the dotted line in the graph. So you are first visiting L, then E, then again E, then T, then F, then again E, then T, F. You follow this dotted line until you reach to the root. Means you start from the root, you go from left side and like this, and again you reach to the root. So this is called as a depth first traversal. I know that many of you might be familiar with the pre-order traversal or post-order traversal. If not, I suggest you read that content, and that will definitely help you to make your ideas crystal clear in your mind. It will remove some whatever confusion is there in your mind. So in next session, we shall talk about how to generate this AST from the given grammar. Only for hint, I am just showing you 2 slides only, and then I am ending you. Sorry for it. So here the purpose of this slide is simply I want to ask you that how the parse tree is generated, because we cannot generate directly AST. Please note this thing. We cannot directly generate AST. We have to generate the parse tree. And how we generate the parse tree, I have asked last time. We have to derive that statement. So this is a basic parse tree. This is a basic parse tree for the given statement. 9 plus 5 plus 2 is equal to 16, like, and L is there at the end. So tomorrow we shall discuss about it. I am just ending it, just showing you only just for scanning purpose some slides. So this is a kind of derivation for the statement 9 plus 5 plus 2 n. N is a written, means a enter symbol or enter key. So this is a derivation. So if you match this derivation with the tree, see on one side there is a parse tree, or you can call it as a syntax tree. So it is generated corresponding to the derivation. Derivation means what? It is substitution. So there are rules like 1, 2, 2, 3, 5, 7, 5, 7, like, and at the end you get the complete parsing, successful parsing. So whatever the sequence you are doing the substitution, here we are using leftmost derivation. You can use RMD also. That is not a problem. But my objective is that to tell you that how parse tree is generated. Parse tree is generated as per the sequence of derivations. So if you trace that parsing derivation, first L is there, then E is there, then again E is there. So all those are underlined in the derivation. And you will find that in tree also, same sequence is there. L, E, 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 T, F, again T, F, T, F, and lastly, that written is there. So digits are there. So digits means something like this. So I hope you understood exactly how the parse tree is generated. Now, in next session, we shall see how the AST is generated from the basic parse tree or basic syntax tree, which is generated from the derivation. Now, what I want to say is that your derivation can be it can be bottom up, or it may be top down derivation, or it may be LL parsing, or it may be LR parsing, like that. So you just keep this in mind. I am sorry, our time is over. It's not possible to cover everything, but still we have sufficiently covered the contents. We are now near to finish the 4th unit. No matter we have 2 lectures per week, still we are sufficiently able to cover sufficient syllabus. So again, I appeal you, if you have any difficulty, you can send me personal WhatsApp. I will address it. And if it is something, I will even try to cover it in some session. But problem is that you people are not asking anything. Anyway, whatever screenshots you have collected today, you just send it to me on my personal WhatsApp. So thank you for listening me. I hope you are taking care of your health and your family. Take care of your health. Thank you. I am ending.